Take out your highlighter. And the next definition that we're going to learn is a reference angle. So we'll write it off to the side. Reference angle. The reference angle for any angle in standard position is the positive angle back to the nearest x-axis. It's a lot of words, but the definition actually is really easy. So here I have three different angles. In quadrant 1, if I have an angle of 35 degrees, the reference angle is how far is it back to the nearest x-axis? 35 degrees. In the second one, if I have 145 degrees, you say, well, how far is it back to the nearest x-axis? 35 degrees. How would you calculate that if you knew this was 145? Well, you would say to yourself, the whole thing is 180. So if I did 180 minus 45 degrees, I'd figure out that my reference angle is 35 degrees. In quadrant 3, if you know the whole angle is 215 degrees, well, this would be my angle back to the nearest x-axis. That would be my reference angle. It would be 35 degrees. And you could take 215 and minus 180 degrees to find that. And if I had a reference angle of 35 degrees in quadrant 4, here it is, back to the nearest x-axis, that would match up with a standard angle of 325 degrees. So what we're going to do with each of these angles, we're going to take out our calculator. And I would like you, let's split this up so it doesn't take as long. Okay, rows 1 and 2, you're going to find sine of 35 degrees, 3 decimal places please, cos of 35 degrees, and tan of 35 degrees. Row 3, you're in charge of sine of 145, cos of 145, and tan of 145. Row 4, you're in charge of sine of 215, cos of 215 degrees, and tan of 215 degrees. And finally, rows 5 and 6, you're in charge of sine of 325 degrees, cos of 325 degrees, and tan of 325 degrees. Okay. Someone in row 1, what's sine of 35 degrees? 0.573. What's cos of 35 degrees? 0.819. You can write them down. And tan? 0.7700. Okay. Excellent. Row 3. Sine of 145. 0.573. Cos of 145. Negative 0.819. And tan of 45? Negative 0.7. Okay. Row 4. Sine of 215, sorry. On your calculator, row 4. Oh my God. Yeah, your row. Oh, wait, we'll go to row 5. We'll come back to row 4. Sine of 325. Negative 0.573. Cos of 325. 0.819. And tan of 325. Negative 0.7. Okay, back to row 4. Sine of 215. Negative or positive? It's It's negative, okay. Cos of 215. And tan of 215? 0.7. So now what we're going to do is, yes? Is it round up to 574? Okay. So that 4, rounded to 4, rounded to 4, thank you, rounded to 4. Now what we're going to do is in a green pen, we're going to circle the positive ones. This one is a positive value. This one's positive. This one's positive. These are the ones in quadrant 1. In quadrant 2, are there any that are positive? Just the first one, okay. In quadrant 3, it's only this one that's positive. In quadrant 4, this one's positive. Something special happens. Something special happens with reference angles. And this is the key thing for understanding trigonometry going past 90 degrees. The idea is this. When I'm looking at 145 degrees, I can make a triangle over here that matches up with the same triangle over here. And because those triangles are the same, the opposite sides, this side was opposite here, this side is opposite there, they're the same length. These sides that are the adjacent, I could make the same length, and my hypotenuse would be the same length. And for that reason, sine, cos, and tan of 145 degrees are very similar to sine, cos, and tan of 35 degrees. However, because we're dealing with coordinates, would you agree if I picked a point here, it might be like maybe over 2 up 1? But if I picked a point here, can you tell that the x coordinate would be negative? Okay? And when I do sine, sine is the opposite over the hypotenuse. Would the y coordinate be negative? No. So we'd have a positive number over a positive number. Sine stays positive in quadrant 2. However, cos, because it's adjacent side and that adjacent side is to the left and is negative, now my cos value is negative. And tan, which is opposite over adjacent, since the opposite is positive and the adjacent is negative, tan is negative. So one of the things you have to know in grade 11 is when trig ratios are positive and when they're negative. So what we did here with 35 degrees is true for any angle. Any angle you pick, if you use the reference angles throughout, all of the values would stay the same for sine, cos, and tan, but sometimes they're positive and sometimes they're negative. And we use something called the cast rule. It's probably the easiest rule in the world to remember where things are positive. The cast rule is basically you draw 4 quadrants. You start with C down here, A, S, T to spell cast. That's why it's called the cast rule, just because it spells the word cast. And the A means that all 3 are positive. In quadrant 2, the S means that sine is positive. In quadrant 3, the T means that only tangent is positive. And in quadrant 4, the C means only cos is positive. If you have trouble remembering the cast rule, come see me. I will teach you the ax rule. Okay? If you can't remember the cast rule, I'll teach you the ax rule. Maybe that works better for you. Well, the cast rule you should, but only if you don't understand the cast rule, you should write down the other one. A stands for all. They're all positive in quadrant 1. So one of the things you'll be asked to do is find reference angles. So they've got some more examples at the bottom of the page. If you've got 155 degrees, what would the reference angle be? $25 degrees. There it is. If you've got 235 degrees, what would the reference angle be? 55 degrees. Again, back to the nearest x-axis. How would you figure this one out? The math you would do is you would do 180 degrees minus 155 degrees, because 180 is all the way, minus the 155 would give you 25. To figure out the 55 degrees, (235 degrees minus 180, right? This is the 180 part. Take that away, and you'd be left with just 55. And finally, if you have something in quadrant 4, 310 degrees, all the way around is 360. If you minus 310 degrees, you'd be left with the reference angle of 50 degrees. So let's add one more to see if you could do one. How about a negative angle? If I gave you negative 100 degrees, what would the reference angle be? It would be 80 degrees. No, close.
90.
Yes, you're right. It's 80. There's your... Because what does a straight line add up to? A straight line adds up to 180 degrees. So let's do, let's go to one other topic. We're going to skip this next little bit and go to this topic here. Trig ratios. If you draw a circle with a radius of r, you can always take any point on that circle and make a right-angled triangle, where this would be your x-coordinate and this would be your y-coordinate. Does that make sense? If I take any point on a circle, I can draw a right-angled triangle by going back to my nearest x-axis, using my reference angle. And what do you know about triangles? That's a right-angled triangle. Would you agree that x squared plus y squared has to equal r squared? Okay? Does that make sense? That's just Pythagorean. Did you know that Pythagorean is also the equation of any circle? If you were allowed to type that into your graphing calculator, that would draw a perfect circle. But your graphing calculator only lets you do y equals, so you have to get y by itself, which isn't too bad, right? If you wanted to type that into your calculator, you could, y squared would equal r squared minus x squared. What would you have to do to get y by itself? And square root. And when you square root both sides, what do you have to remember? Plus or minus. So that's why it takes two equations inside your graphing calculator to graph a circle. You have to draw one with the plus and one with the minus. And from this picture, they say that cos is always adjacent over hypotenuse, so cos is always x over r. Sine is always y over r, and tan is always y over x. So we're going to get questions like example 1, which we're going to do right now. This is a trigonometry unit, and so our main strategy in trigonometry will be to draw this is multiple choice, square, rectangle, circle, or triangle. Yes. Good job. I said this is a trigonometry unit, so our main strategy in this unit is going to be, and I gave a multiple choice question, do you think it's going to be to draw a square, draw a rectangle, draw a circle, or draw a triangle? Our main strategy in trigonometry, surprise, surprise, is going to be to draw a triangle. So you've got the point, -2, -4. It's on the terminal arm. Terminal arm is where an angle ends. So an angle in standard position starts where? Positive x-axis. And this angle goes through the point -2, -4. So this angle looks like this in standard position. Once you have an angle in standard position, you can always draw a triangle going back to the nearest x-axis with your reference angle. So in this case, I know it goes through the point -2, -4. I can draw a triangle going back to the nearest x-axis. You can label the sides of this triangle. How long is this side? Oh my, this one? This one's 2. This one is 4. And how long is the hypotenuse of that triangle?
6.
And this is your reference angle. This is a squared plus b squared equals c squared. This will be, mental math for you, 2√5. Can you do that in your head?
4.5.
No.
I rounded it up.
You rounded. Okay, but we'll leave it as an exact answer. How did we get 2√5? You would go 2 squared, a squared plus b squared equals c squared. 4 plus 16 is 20. So c has to be the square root of 20, but we can't leave the square root of 20 like that because you could simplify it. Square root of 20, this is our radicals unit, is 2√5. In part A, it says, determine the primary trig ratios of theta. So they want you to figure out what is sine of theta, what is cos of theta, what is tan of theta. And this is where our reference angle comes in. When we look at our triangle with our reference angle, sine of our reference angle would be 4 over 2√5. We would also have to use our cast rule to determine should that be positive or negative because it's in quadrant 3. Should sine be positive or negative? It should be negative because sine is always negative in quadrant 3. You wouldn't be able to leave your answer like that. You'd have to simplify. 4 over 2 simplifies to 2. You would also have to rationalize your denominator. And so your final answer will be -2√5 over 5. Cos of theta. So we look at our reference angle. Cos is adjacent over hypotenuse. The adjacent side is 2. The hypotenuse is 2√5. Will cos be positive or negative in quadrant 3? How did I get a 5 on the bottom? Well, √5 times √5 is 5. And then the 4 and the 2 simplified. So same thing here. You'd have to rationalize your denominator. Oh, It needs to be negative, right? Because it is in quadrant 3. Cos is negative in quadrant 3. The 2's will cancel. And we'd get negative root 5 over 5. And finally, tan of theta. Look at our triangle. What's tan of our reference angle? Opposite over adjacent. Is tan going to be positive or negative in quadrant 3? According to the cast rule, it's going to be positive. 4 divided by 2 simplifies to just 2. And we have figured out all 3 trig ratios. Once you've figured out all 3 trig ratios, now, do they kept them unrationalized? They kept the root 5 on the bottom?
Yeah, they're simple.
Yeah, they haven't simplified it.
You should write a new book.
Should write a whole new book. And then in part B, we have to find the angle. Whenever finding angle, first you're going to find the reference angle just using the triangle that you have. Would you like to use sine, cos, or tan with your reference angle?
Sine.
Why would you like sine?
I don't know.
Okay, let's go with sine. Sine of your reference angle is negative, well, sine of your reference angle opposite 4 over hypotenuse 2 root 5. When dealing with your reference angle, everything is positive all the time. Okay? When dealing with a reference angle, you always use positive values all the time, because a reference angle is based on grade 10 trig. In grade 10 trig, you never did sine inverse of a negative number, cos inverse of a negative number, tan inverse of a negative number. So we go to our calculator. How would I find my reference angle? I would type in sine inverse of this. So I go, tan would have been nicer because the numbers are nicer, but that's okay.
Sorry, T.
So we go sine inverse 4 over 2 root 5. And we find out that our reference angle is 63.4 degrees. Did it ask to the nearest degree? Our reference angle to the nearest degree is 63 degrees. Because that's we need to find our actual angle in standard position. Look at our picture. Which angle did we just find? We just found out that this angle here is 63.4 degrees, and we need to find this whole big green angle in standard position. How would you do that? If this is 63.4 degrees in the triangle, what's this big angle going to be? It's going to be 180 degrees plus that 63 degrees, which is 243 degrees. Okay, questions to try. 6, 10, and 11.